Hello everyone. So in this video I will be going through kind of an intro example to the Galapagos tool, which is found here in the utilities in Grasshopper. And we'll actually also be using this just to kind of give something a little bit more interest. We'll use this alongside the Ladybug view percent tool. I'm using, this is at the time of this recording in late October of 2020, Ladybug recently just released the 1.0 version, which is a big upgrade from the old one. So if something looks different from what you might see in Ladybug, it might just mean that you have to update, or it might mean you're really far in the future and now I'm behind. So with that said, the view percent tool is really it's really just a convenient way to kind of do projections out and see where a vector would hit some piece of context. So it's not really tying into weather data or anything like that, um, but it's really just a convenient way to do projections. All right, so with that kind of said, what you see here is I just kind of dropped this in to save some time, but this was something that we built earlier in the intro kind of courses for Grasshopper. But basically all it is it's kind of this twisty tower thing, and you can increase the floor height, and you can increase the number of floors, and you can increase, the twist between each floor. So that's kind of all. It's not nothing too super fancy, and this is just like an ellipse. And then for each floor, you rotate it, 6 degrees in this case, and then you can loft it and have the floor plates here. So this is kind of the starting point just to save some time in the video. And I'm going to turn these on. So you see here I kind of have some dummy context just to kind of for the purpose of the demonstration. Now, what we want to do here, Galapagos, what it is it's an evolutionary solver tool. So what it allows you to do is basically kind of play around with optimizing among a variety of kind of parameters, essentially. So you have what's called like a fitness parameter here, or a fitness value, which is what you're either trying to maximize or minimize. And then you have like a number of genetic inputs. So these are kind of the sliders, essentially, that you're going to be playing around with, and you can have multiple kind of inputs, which is really where like the Galapagos tool comes in handy when you're trying to sort of you have multiple things changing at once and you want to figure out what the right combination is. So right now we don't really have too much in terms of like what we can change other than like this kind of like rotation, a twist and whatnot. So what I want to do ultimately is I want to basically find kind of I'm going to give like a set. I'm not going to change the number of floor plates or the height. I want to keep that as a constant, but I want to, based on like a twist and based on like where this building is placed and how it's rotated, I want to try to optimize the view percent in this particular site. So that's kind of what the overall goal will be for this exercise. So with that said, I'm going to add, in addition to the rotation, I want to add a couple other things. So I'm going to do kind of just the placement of the building on the site. So I'm just going to do it along the x-axis, just to kind of just to keep it simple. If I was really doing this, I would probably want to, do the x and the y. But I'm just trying to do this quickly. And I might change this to say, and so the building right now is located at the origin, so I'm just going to be moving it, negative 50 feet or to the left or 50 feet to the right or whatever. So X location, so this will be one of my inputs here. And then this, let me remove this from the group so that I can kind of pop it here. And so I'm going to move these points, and then that'll feed into here. And it looks like, so I have to rotate around those points as well. All right, so now you see that this building kind of moved within that site. So I want to figure out, one of the inputs is going to be, where along this line do I want that building to be? And then the last one I'm going to do is I'm going to do like a rotation. So I'll just do a plane, rotate plane, and I will, let's do this. So most Grasshopper tools take radians as an input, but most of us think in degrees. So I'll do 0 to 180 for the kind of rotation. All right, and so this will rotate those planes, and I'll actually feed this into here. So now the whole building will, rotate both at the base, and then you can have kind of the rotation between floors. So like one thing, if I was, as we're doing this, we always want to think about both, just not just kind of the optimization part, but there are certain design decisions that we want to be able to kind of limit and whatnot. So in this case, I don't really, I want something a little bit more interesting. I don't want this to ever be 0 as an option, so maybe I'll just say like 3 to 12 or something as my degree options. This way I kind of limit it so that I at least get something. Where is this going? I at least get something a little bit, at the very minimum, there'll be a little bit of a twist to it. All right, and then this is, yeah, so that's the twist in degrees, and then this is the floor to floor angle. All right, so these will be kind of my 3 inputs into my genome parameter here. So yeah, I'll just go ahead and connect those now. So genome, the wires are a little weird. They're a little different than all the other tools. Whoops, to hold shift to add multiple ones. So those will be my 3 kind of inputs that I'll be changing. So again, the overall rotation of the building, the X location, and the floor to floor twist. All right, so we have that set. And so now the next thing I want to do is kind of figure out what figure out this view percent tool. All right, so actually before I do that, what I want to do also is realistically I'm going to have like a building core in here. I say realistically as if this is a real building, but it's obviously not. But we'll kind of do something to make it a little bit more kind of realistic, I guess. All right, so I'm gonna just grab the first and last item using the list item tool of the planes here. And for the last item, you can, little trick is to do -1 here. So now I have the top and the bottom. And I'm just gonna make a circle. And I'll give it a radius of, I don't know, 15 feet. I'll do another one here. And then I'm just going to loft these. So let me disable this just so we can see it a little bit easier. All right, so we have kind of our building core in there. Maybe I'll make it a little bit bigger. Maybe I'll make it 20 feet or so. That's a little big. 17, sure. All right, so we have our building core, and so I'm just going to plug that in here, and I can kind of turn off the preview for these. So we've got our building core, our ground plane, our context, and our floor plates. So now what we can do is we can begin to plug these in. So you see in the view percent tool, essentially anything where it starts with an underscore and doesn't have an underscore at the end, or it's like a required input. That's true with all Ladybug tools. I'm not going to this isn't really meant to be a Ladybug tutorial, so I'm not really going to be going too much in depth here, but you can always, the documentation for all their tools are really great, so you can always hover over here and understand. There's very detailed descriptions of what everything is and the tool itself, and so the first thing we need is the view type. So you can see here, this is probably the most important thing to read for this tool, is what kind of view type you want to analyze. Do you want to do just a horizontal radial? Do you want to do a horizontal 30 degree, which kind of mimics more like the human peripheral vision? Do you want to do a spherical? Do you want to do sky exposure or sky view? In this case, we're kind of like mimicking some sort of analysis where we want to optimize the view for a person, kind of in the building on the floor plate. So I'm going to use the 30 degree kind of peripheral view option here. And I'll show you kind of what vectors that makes in a second. And then the geometry is going to be our floors. This will be like where we're analyzing things from. The context is going to be the context, the ground plane. It's important that you have a ground plane here, otherwise it'll kind of shoot vectors past the ground. And then the building core. So essentially I'm putting in anything here that would potentially like block a view. So that's why I'm putting that's why I made the building core. And that's why I made the ground plane. And even the floors themselves would be blocking, if someone's sitting in here, they might not be able to see 30 degrees all the way up because of the floor plate above. So I should even add the floors themselves as part of the context. And we can avoid kind of like the floor kind of hiding itself essentially by doing this offset here. They always have like a default for the offset distance. In this case, I'm going to do, my Rhino is in feet right now. I'm going to do a 5-foot offset, which is kind of like the height of a person's eyes, maybe, roughly. And then my grid size, if I was doing this on a real project, I would make a finer grid and run this for a longer period of time, but because I want to try to keep this quick and simple, I'm just going to do a pretty big grid, like a 10-foot grid. And then the last thing we'll need is a toggle to run it. And I'm gonna kind of leave the other stuff for now. And let me just double check what this is. So we're doing the horizontal. It's false for that. So I'll add another toggle for that. I'm not sure what the default is here, but just to make sure, I'll put false in there for the geo block. All right, so almost ready to run this. Trying to think if there's anything else. Actually, we are ready to run this. All right, so let's run it and see what happens. So this will take a couple seconds to run, but you can kind of see it's fairly, it looks right. We have basically the percentage of view that it can see from each the points on these floors. So like the lower you are, essentially the less you can see, the higher you are, the more you can see, which makes sense, and the closer you are to the edge of the floor plate, the more you can see, so that also makes sense. So this, can kind of just really quickly say, all right, this looks about right. And just to kind of show to visualize like the vectors of what this projection is doing, we can use the vector display tool. You don't have to do this. I think it's helpful for the explanation of the tool. And we'll just look at one of the points. There's going to be probably a few thousand points in here. Let's just picking a random point. So we can see there's a point there. So that'll be my anchor, and then there's these view vectors here. So again, I'm gonna just increase the amplitude of the vector so we can see it a little bit better. Alright, so you can see now what that kind of 30 degree, it's kind of looking 30 degree from the horizontal plane up and down essentially. So it's, you know, not quite like a spherical view, but it's kind of cropped. So at every point, it's kind of just doing these projections and seeing where, you know, whether or not it hits something. Um, so, you know, it's fairly straightforward, but this tool just kind of gives you a lot of convenience in terms of you could probably do something like this without using like any plugins or anything, but this just makes it really convenient and nice. All right, so I can turn that off. Um, all right, so what we're getting at here is in terms of the results, or these are all the percentages for every point. And all our points are kind of just the points from that are kind of the center or the faces of the mesh, essentially. So these are all the points that are getting analyzed. If I had done a tighter grid, I would have got more points, etc. So that is that. And so what we want to do here, a quick way we can do this to as far as getting what we want is one value to plug into this fitness input here. So I'm just going to do a mass addition of the results. And so this is just going to give me kind of one value, adding all those results up. So I can kind of see that if I were to, you know, move my floor angle to, you know, 5 degrees, so now that ends up giving, you know, better visibility uh, percentage. So this is a fairly like dumbed down approach to this. In reality, you would, you know, do something more fine-tuned, but this is just to kind of demonstrate the workflow, and then you can kind of adapt it to whatever you need. All right, so we have that set. So this is going to be our fitness number here. And then we can start to run the analysis. Now I'm gonna, just to make it a little bit faster, I'm gonna turn off the preview here. I think that'll make it a little faster. And what we can do, just so we can kind of see what's happening, is, so this is the result, and then these are my inputs, and this is my building. All right, so if we double click on here, you get this like weird little interface thing here. It's a little bit cryptic, but and I can't really explain a lot of it, but the kind of important things to know are essentially every time you run an iteration of the solver, it's going to kind of pick. At first, it's kind of just completely random, and the initial boost will essentially do whatever 2 times the population. So the first time it runs, it's going to do 2 times of what it will run every time after that, just to kind of get a little bit larger of a sampling for that first random kind of iteration. And then every iteration after that, it gets somewhat kind of less random, is kind of a dumbed down way to think about it. But this population number here is basically, you know, the number of iterations that it's going to run in every, or the number of like different configurations of these numbers it's going to run in every iteration. And so then there's kind of like a bunch of things up here. Essentially, you kind of set your options here. For the sake of speed, I'm going to make this like, I'm just going to reduce my population to 30. And then you can come to the solver here and run it. And so that started, and you can kind of begin to see, hopefully, so now you see that it's kind of picking a bunch of random configurations of these three inputs, and I'm getting different results out each time. And so this will take a while to run. If you're running this on, um, like if you're doing this in addition with like a radiation or a sunlight hours analysis, it would probably be even slower because there's a little bit more in terms of the analysis going on there, potentially. Um, so just kind of keep in mind that the more computationally expensive your script is, the slower this is going to be. And I'm actually going to pause the recording so that we're not, because this is probably going to take me like the computer 10 minutes to get to something that's close to optimal. So I'm just going to pause the recording here and I'll pick it up um, once I have a little bit more. Alright, so you can kind of see I've let this run for about 10 minutes now, maybe a little less. And it's kind of run through 10 different cycles. The first one was longer because it was kind of 2 times the amount of samples. And so what you can kind of see here is that we're beginning to kind of flatten here, which means that we're starting to kind of converge on an optimal arrangement. And what you see down here are kind of my top results. So like this number that it's trying to maximize is essentially these different options here. And it can kind of tell you like basically these 3, 1, 2, 3 points are my three kind of inputs. And it's kind of just doing different combinations of those. And so, I can let it go if I wanted to, and maybe there might be one or two other options that are just as good or if not better, but I'm just going to stop it for the sake of speed. And so what you can do once you stop that, you can kind of see if you look at, you can kind of display the different like top 10% or all of them or whatnot um, of the different. So these are like it started off just kind of doing like a lot of really random options, and then as it went, it kind of converged on some options that were you know more set. So it looks like this last one here, just based on the spacing of things, it looks like this last thing was the degree of rotation between floors. So it was probably like 0, 1, 2, 3, 4, 5 or something. Anyway, um, so we can kind of look at the different configurations here. If we wanted to reinstate, let's say like we wanted to look at a couple of the top options, I can reinstate this and see what those rotations were and things like that. Or I can reinstate this one. So I can kind of look here and say like make a more kind of a intuitive decision as to which one I would want, or I can just kind of pick the top one if I wanted the kind of absolute maximum option. So I can reinstate that, and that'll kind of reset the numbers to that option. So now I know that this is the option, and maybe I'll preview this again just to make it pretty. But this was basically the option that gave me the maximum kind of total view or view percentage when added up of all the points. So that's kind of it as far as the Galapagos tutorial goes. And if you wanted to, like the next steps could potentially be if you wanted to get this information back into Revit, you can kind of use Rhino inside in order to bring that back in. I have another tutorial video that goes through something similar where I used the view rows tool in order to assign kind of a view score to rooms. So you can do something like that if you wanted. Or you can kind of just display it in Rhino and Grasshopper and visualize it in within here. So that's it for the video, and thank you.